Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. NaNH2 is a very strong base, pKa of NH3 38, capable of deprotonating terminal alkynes and also acts as a base for elimination reactions. Moving on to the next step. Identify the starting material. The compound is PHCCl, CH3, I, 1-chloro-1-phenylethan, 1-vial, a secondary benzylic chloride with structure PHC, Cl, CH3, where the carbon-bearing Cl also bears a methyl group and a phenyl group. It is actually PHCHCl, CH3 based on structural drawing, a secondary benzylic chloride, 1-chloro-1-phenylethan. Wait, re-examining the structure, PHC, CH3, Cl, with a vertical bond to Cl, meaning the carbon has pH, CH3, Cl, and one implicit H, so it is pH, CHCl, CH3, I, 1-chlorothyl, benzene or 1-chloro-1-phenylethan. Moving on to the next step. First equivalent of NaNH2 acts as a base and causes dehydrohalogenation, E2 elimination of pH, CHCl, CH3. Removal of the beta H from CH3 gives PHCH is equal to CH2 styrene. This accounts for one equivalent of NaNH2 producing NaCl and NH3. And for the final step, second equivalent of NaNH2 performs another elimination, but styrene, PHCH is equal to CH2, is a vinyl system. NaNH2 can abstract an allylic vinylic proton and cause isomerization or further elimination. NaNH2 is strong enough to deprotonate a vinylic position. The base abstracts a vinylic proton from styrene, generating a vinyl carbanion, which leads to the formation of PHCCH, phenylacetylene, via elimination of H-. So, PHCH is equal to CH2 plus NaNH to PHCCH plus Na plus NH3, or via base-induced 1,2 elimination of H from vinylic position. This accounts for the second equivalent. Third equivalent of NaNH2 deprotonates the terminal alkyne PHCCH, pKa 25, since NaNH2 is strong enough, pKa of NH3 38. This gives PHCC, Na, plus, sodium phenylacetylide, and NH3. This accounts for the third equivalent. Overall, PHCHCl, CH3 plus 3 NaNH2 PHCC, Na, plus NaCl plus 2 NH3 plus Na, or equivalent byproducts. Why other options fail? A. PHCH is equal to CH2 is only the intermediate after first elimination, not the final product. B. PHCCH is the product after two equivalents of NaNH2, but the third equivalent deprotonates it. C. PHCH2CH3 would require reduction, not elimination. NaNH2 is a base, not a reducing agent. D. PHCC Na plus is the correct final product after all three equivalents of NaNH2 are consumed. Therefore, the correct answer is D. Therefore, the correct answer is option D.